Hi there, welcome to this lesson on pure mathematics, and in this lesson we're looking at quadratic inequalities. Now, solving a quadratic inequality, the easiest way to do it is to first of all sketch a graph of the quadratic function in the inequality, noting in particular the crossing points on the x-axis. They're always significant. I apologize for the noise in the background if you can hear it. It is the sound of rain falling on the roof. The solution, once you've done the sketch of the quadratic, will be those values of x for which the graph is either above or below the x-axis, depending on what they ask you to find in the question. Sometimes the question won't be framed in terms of a quadratic function, and you'll have to do a little bit of work yourself first, rearranging it, moving things around, so that it looks like a normal quadratic before you begin the question. Okay, first example. Have a go at this one yourselves. So sketch the graph and then write down what you think the set of values are for which the quadratic is less than 0. Pause the video, come back to me when you're ready. Okay, we'll have a look at this together. So if you're going to sketch a quadratic or any curve, the first thing I would always do is find the crossing point on the y-axis, because it's the easiest thing to find. The crossing point on the y-axis is when x equals 0. Now, if x equals 0, then this function here will just equal -6. The x's will vanish. Then to find the crossing points on the x-axis, we do the same thing, but we say what happens if f of x is equal to 0, if y equals 0. Now, if f of x equals 0, that means that x squared minus x minus 6 equals 0. That does factorize into two brackets, x minus 3 times by x plus 2. If the first bracket equals 0, that'll mean x equals 3. If the second bracket is 0, that'll mean that x equals -2. And at this point, we can sketch it. So the quadratic will look something like that. Crossing points at -2 and 3 on the x-axis, crossing point at -6 on the y-axis. Then we just need to come back to the question and what we were actually asked to do, which was, when is this function less than 0? Less than 0? That means it'll be beneath the x-axis. So the function is less than 0 from -2 up to 3. And everywhere else is bigger than 0. It's above the axis. And that'll be the answer. The required set of values is x lies between -2 and +3. Okay, the second example has a few more parts to it. The first part is just looking at a linear inequality, solving for x minus 3 is less than 9. That is very straightforward. Don't make it complicated. The second part is sketching a quadratic again and solving a quadratic inequality. You'll need to move things around here so that you have everything on one side of the inequality sign and 0 on the other side. Now, once you've done that, then use your answers to the first two questions, first of all, to find the set of values for which both inequalities are true. And then after that, slightly different, but importantly different, then use your answers to 1 and 2 to find the set of values for which either one equality or the other inequality is true. And it's the distinction between both and in question 3 and either or in question 4 that really matters, that you need to make sure you understand well. Okay, have a go at doing this yourself first, and then come back to me when you're ready. Okay, we'll have a look at this. So the first part was just the linear inequality, 4x minus 3 is less than 9. And to solve that, there are no tricks, no catches. We add 3 to both sides, and that gives us 4x is less than 12. Then we divide by 4, and that gives us x is less than 3. That's the linear equality solved. You don't need to do any more. To do the quadratic, we need to sketch the curve. But before we can do that, we need to rearrange things so that it looks like a normal quadratic inequality. So moving everything to the right-hand side and collecting terms would give me that. Now, you don't have to do this next thing, but I would always choose to write the x's first. That means you need to swap the inequality sign. So both things say exactly the same thing, that x squared minus 2x minus 8 has to be greater than 0. And then we'll sketch the function. Same as before, first of all, we'll find the crossing point on the y-axis. If x is 0, the function will equal -8, so that's where it'll cut through the y-axis. If f of x equals 0, that means x squared minus 2x minus 8 equals 0. Again, that does factorize into x minus 4 times x plus 2. And the two solutions are, first of all, x will equal 4 for the first bracket, and then it'll equal -2 for the second bracket. Now we can sketch the quadratic, and it'll look like that, crossing points at -2 and 4, and -8 on the y-axis. Then we need to come back to the question, and the question asked us to find when this inequality is true. We rearranged that to give something more understandable, which is when is this quadratic greater than 0? But these statements mean the same thing. So to answer the question, we just need to say when the function is greater than 0. Well, that means it's got to be above the x-axis. So it'll be this stretch here on the left-hand side and this stretch here on the right-hand side, which is when x is less than -2 or when x is bigger than 4. And that's the answer. That's the required set of values. Now, part 3 was asking us to use both of those answers for 1 and 2 to find the set of values for which both inequalities are true at the same time, which is what that means. The significant word there is and. It turns up in probability as well and in set theory. And it's important that you understand the difference between and or in a mathematical context. Now, you don't have to draw a number line, but I think it makes it easy to see what's going on if you do. So the number line for the first inequality was x has to be less than 3. So that's what we have there. X is less than 3. It's a hollow circle at the end because it doesn't include 3. And then we've got two inequalities for the next bit. X is less than -2 and x is bigger than 4. That will give us those two things. And then we want the set of values where both of those things are true at the same time. Now, the only range that that is true for is this range here, where x is less than -2. They're both inequalities are true at the same time. Everywhere else, only one of them will be true. So the answer will be that x has to be less than -2. Part 4 is asking a subtly different question, but as I said before, the difference does matter. This time it's saying, when is either one equality true or the other inequality true? Now, what they mean by that is they don't mind which is true. So either the first one can be true, or the second one can be true, or both can be true. But it really doesn't matter, as long as at least one of them is true. Now, that's the case nearly all of the time. There's just a tiny range between 3 and 4 when neither inequality is true. So for that small distance there, no, neither inequality is true, but everywhere else, at least one of them is. And that'll be the answer, what we have at the bottom there. So x is less than 3 or x is bigger than 4. Okay, final example, example 3. Asks you to find the set of values for which 10 divided by x is greater than or equal to 5. And I'll go through the start of this with you because it's so tempting to do something which turns out to be very problematic. It's very tempting just to multiply through by x straight away and get 10 is greater than or equal to 5x. Now that would be fine if this was an equation. So if it said 10 over x equals 5, you could definitely write that means 10 equals 5x. But it's only true when you have an equation. The problem with inequalities is if you multiply or divide by a negative number, you have to change the sign. And because we don't know what x is, it may be negative, it may be positive. It becomes a problem if you multiply by it, because the sign may need to change or it may not need to. And the way we get around that problem is we multiply through by x squared instead. And the reason why we multiply through by x squared is because x squared is guaranteed to be a positive number. So multiplying through by x squared gives us 10x is greater or equal to 5x squared. Moving things to the right-hand side gives us 0 is greater than or equal to 5x squared minus 10x. Factorizing the right-hand side gives us that. And then as before, I would always choose to swap sides so that we have the x and 5x minus 10 on the left-hand side, remembering to swap the sign when I do that. So x into 5x minus 10 has to be less than or equal to 0. Now we need to sketch that as a quadratic, and I'll let you finish this question off. It's nearly all done. So sketch the quadratic just like we did on the previous two examples. and pause the video, and then come back to me when you're ready. Okay, well, sketching the quadratic. The first bit's been done for you. The crossing points on the x-axis are where x equals 0 or where x equals 2. So if 5x minus 10 is 0, then that will give us x equals 2. The only crossing point on the y-axis is at 0. So this curve goes through the origin, and it goes through x equals 2, which means we could now sketch it, and it would look something like that. Then going back to the question said, when is this function less than or equal to 0? Well, it'll be less than or equal to 0 when it's underneath the x-axis, so between 0 and 2. And that is the question done. All we need to do then is write down the answer, which is that the required set of values is that x lies between 0 and 2. Note this time we got greater than or equal and less than or equal there. That matters. It's because that was the sign they used in the question. So if they use greater than or equal in the question, make sure you're doing the answer. If it's just strictly greater than or less than in the question, then it'll be the same in the answer. That gets us to the end of this lesson. If you've got the textbook, turn to page 48 and have a go at exercise 3E. Thank you very much for listening, and cheerio.